primary method developers used to interact with large language models was quietly deprecated in favor of a new architecture. Boris Cherny, the creator of Claude Code, outlined the exact nature of this change. "I don't prompt Claude anymore. Loops prompt it. My job is to design the loops." To understand why that single sentence redefines AI development, look at the legacy cycle most users still rely on. You type a specific task, you hit enter, and wait for an answer. You read the diff, you locate the flaws. You rewrite the text and resubmit the request. This process traps the human in the middle of the execution cycle. The user serves as the manual error checker and the connective tissue between every single iteration. The replacement for this manual process is loop engineering. It abandons single-shot text requests entirely. Prompt engineering is a static exercise in string manipulation, trying to write a paragraph to get the right answer on the first try. Loop engineering is system architecture. You build a closed-circuit framework that prompts the agent programmatically, forcing it to evaluate and refine its own outputs until a specific condition is met, without waiting for your keystrokes. Building these loop structures is the only way to scale AI development to match the raw throughput of machine compute. There is a massive discrepancy in processing speed between an LLM generating tokens and a human reading them. A model can output hundreds of lines of complex logic in milliseconds. It then drops to zero utility, sitting completely idle while it waits for a human to read, comprehend, and evaluate that code. Looking at a standard linear workflow, the halt state is obvious. The data flows instantly through the prompt and the LLM, but halts entirely at the user node. The delta between the LLM's completion and the user's next input is pure dead time. The compute sits idle while the human reads. A single generation rarely yields a production-ready feature. Complex coding tasks require dozens of iterative revisions. When your architecture relies on a human for multiple rounds of revision, you multiply that dead time across every single cycle. The delay compounds. Humans also suffer from severe cognitive load. A developer forced to meticulously read and evaluate hundreds of lines of AI-generated syntax across rapid cycles will quickly burn out and miss critical bugs. A programmatic loop in agentic software development directly targets this point of failure. It replaces manual human evaluation with automated routing logic. The output of one LLM call becomes the direct input of an evaluation call, keeping the data flowing at machine speed. Removing the human from this micro-execution layer is a structural requirement for scale. To see how this executes in practice, we can look at the LangChain for-loop playbook, a foundational architecture for building these autonomous pipelines. This nodal map illustrates the first mechanism, the reflection loop. It splits generation and evaluation into two distinct, automated steps. The evaluation node rigorously audits the output against a strict set of constraints, forcing revisions before a human sees the draft. Next, the execution loop connects the agent to its environment. By giving the system access to a compiler, it runs the code. Hitting a runtime error feeds the stack trace back to fix the syntax. For massive objectives, the system relies on the third layer, the planning and routing loop. This node maintains long-term context. Breaking down large inputs and feeding them sequentially to lower loops prevents hallucination during extended runtimes. Finally, the optimization loop operates silently over the entire structure. This layer extracts data from successful trajectories across the other loops. It uses those successes to refine the system instructions, often running entirely overnight. When an automated system optimizes its own logic by even 1% each night, the continuous compound effect is significant. 1% daily improvement yields a 37.8 times multiplier over a single year. Systems using these 4 interconnected loops improve their own reasoning autonomously, meaning human attempts to tweak the initial prompt string cannot compete with the speed of automated iteration. Implementing this architecture requires a progression through 5 specific levels of loop design. This taxonomy maps the progression. Levels 1 and 2 operate on the basic retry logic and automated syntax correction. Level 3 introduces context-aware looping. The system is no longer dependent on manual data inputs. Instead of a human manually pasting relevant documentation into the chat box, the agent independently queries the codebase, reads the necessary files, and refines its own context window before writing a single line of logic. Level 4 shifts the architecture to multi-agent debate. specialized models take on dedicated roles: a writer, a reviewer, and a tester. They employ adversarial evaluation to reject weak logic and raise output quality. True autonomous loop design is achieved at level 5. The human is entirely detached from the execution cycle. The developer strictly monitors system health and sets overarching behavioral heuristics for the agent network, never writing code. This progression shifts the developer's focus toward high-level systems architecture, moving away from the management of low-level string inputs. The era of writing a paragraph of text and waiting for an LLM to output a flawless application is over. Single-shot prompts are strictly capped by human cognitive limits and reading speeds. Loop architecture takes the brutal, time-consuming burden of iteration and transfers it from the human mind to machine compute. While a human sleeps, these systems run hundreds of automated evaluation cycles, testing logic, resolving errors, and updating their internal parameters. This changes the daily reality of building software. The work is no longer about micromanaging an AI's output line by line. When Boris Cherny states that loops prompt it, he means the system interrogates itself. It relies on the routing notes and evaluation protocols you design to find the right answer independently. The technology industry has moved past the micro-execution of individual prompts. The frontier is now macro-architecture, designing the closed circuits that allow agents to reason continuously. Moving forward, high-value engineering centers on constructing the complex infrastructure that makes manual prompting obsolete.